In this video lecture, we are going to see diesel cycle derivation and problems. Myself, I am Rajkumar, Assistant Professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology. Diesel cycle. This cycle, proposed by a German engineer, Dr. Rudolf Diesel, to describe the process of his engine, is also called the constant pressure cycle. This is believed to be the equivalent air cycle for the reciprocating slow speed combustion ignition engine. The PV and DS diagram are shown in figure. First of all, this is the first diagram is the PV diagram. Second one is the TS diagram. In the figure shows the first one 1 to 2. The process 1 to 2 is the reversible adiabatic compression process, and 2 to 3 is a constant pressure heat addition process. Then 3 to 4 is reversible adiabatic expansion process, and 4 to 1 is the constant volume heat rejection process. In these diagrams, we can see the process 2 to 3 means constant pressure process, means that is a P2 equal to P3. Then 4 to 1 process, the constant volume. So V1 equal to V4. In this operation, the air is compressed isentropically from condition 1 to condition 2. Heat is supplied to the compressed air from external source at constant pressure, which is represented by the process 2 to 3. The air expands adiabatically until it reaches the condition 4. The heat is rejected by the air to the external sink at constant volume until it reaches to condition 1, and the cycle is repeated. The actual practice, the engine operates on an open cycle and heat is supplied by burning the injected fuel near the end of the compression stroke. The condition 4 is the condition of the gas at the end of the expansion, and they cannot be used again, and fresh air is taken from the outside from the next cycle. In actual practice, the compression and expansion do not follow the law of PV raised to gamma equal to constant. The cycle is also called constant pressure cycle because the heat is supplied to the working fluid at constant pressure. The work done by the cycle per kg of air and air standard efficiency of the cycles can be calculated. First of all, you can see this, the process 1 to 2 is a reversible adiabatic compression process, 2 to 3 is a constant pressure heat addition, and heat addition, that is Q equal to mCp into T3 minus T2. That means M is mass and Cp is a specific heat at constant pressure. T3 is a final temperature minus T2 is the initial temperature for the process 2 to 3. Then process 3 to 4 reversible adiabatic expansion process. Then process 4 to 1 is the constant volume heat rejection process. In this, heat rejection equal to mCv into T4 minus T1. Then M is the mass and Cv is a constant volume, specific heat of constant volume, and T4 is the final temperature and T1 is the initial temperature of the process 4 to 1. Then process 1 to 2, that is a compression process, that is the RV. That is RV means the volume ratio, that is a V1 divided by V2. Okay, then we know the pressure temperature volume, that means pressure temperature volume relation. From this relation we can take the formula T2 by T1 equal to V1 by V2 the whole raised to gamma minus 1. From this equation we can find the T1 value, that is T1 equal to T2 into 1 by the RV is the that is a compression ratio or the volume ratio, RV the whole raised to gamma minus 1. This is equation 1. Then process 2 to 3 heat addition, that is mCp into T3 minus T2. Here we know the that is a V3 by T3 equal to V2 by T2. From this is the PVT relation. This is the constant pressure process. So we can strike out the pressure value from, so remaining value V3 by T3 equal to V2 by T2. From this value we can find out that V3 by V2 equal to RC, that is a cutoff ratio. So we know we want the T3 value. So T3 equal to RC into T2. This is the equation number 2. Then process 3 to 4, we know the TV relation, that is T4 by T3 equal to V3 by V the whole raised to gamma minus 1. Here we know the value of the multiply and divided by V2 value. So V3 by V2 we know the RC value, and V2 by V1 we know the value of RV, that is 1 by RV. Okay, finally we get the formula T4 by T3 equal to RC divided by RV whole raised to gamma minus 1. From this equation we can find out the T4 value. So the cross multiplication, the RC divided by RV the whole raised to gamma minus 1 into T3. So finally we got the T4 equal to RC into T2, the RC divided by RV the whole raised to gamma minus 1. This is equation number 3. Then process 4 to 1 heat rejection MCV into T4 minus T1. Net work done during the cycle, that is heat added minus heat rejection, that is CB into T3 minus T2 minus CV into T4 minus T1. Here the M value mass equal to consider 1 kilogram. Then as standard efficiency formula equal to net work done during the cycle divided by heat supplied during the cycle, that is a CP into T3 minus T2 minus CV into T4 minus T1 divided by CP into T3 minus T1. Here the common value, that is we can separate the equation CP into T3 by T2 divided by CP into T3 minus T2 minus CV into T4 by T1 divided by CP into T3 minus T2. Here you can strike out the CP T3 minus T2, so that we get the value 1 minus T4 minus T1 divided by T3 or into T3 minus T2. Now the substituting all the terms, we get the value, the thermal efficiency coefficient of the diesel cycle equal to 1 minus RC into T2 into RC divided by RV the whole raised to gamma minus 1 minus T2 into divided by volume ratio, the RV into gamma minus 1 divided by R into RC into T2 minus T2. Here finally we get the efficiency of the diesel cycle equal to 1 minus 1 by RV into gamma minus 1 the whole raised to RC the whole raised to gamma minus 1 divided by R into RC minus 1. Then problem, a diesel engine working on a standard cycle taken in air at 1 bar and 25 degrees centigrade. The specific volume of air at inlet equal to 0.8 meter per kilogram. The compression ratio is 14 and the heat is added at constant pressure is 840 kilojoule per kilogram. Find out the cutoff ratio of the air standard efficiency. So given the first of all value pressure equal to 1 bar, temperature 25 degree, we can convert it into Kelvin. So adding 273, so degree centigrade converted into Kelvin, so we get 293 Kelvin. Then V equal to volume 0.8 meter cube per kilogram. Then compression ratio, that is R equal to 14. Then heat supply Q equal to 840 kilojoule per kilogram. For solution, V1 by V2 equal to 14, that is compression ratio. We know, already given the value equal to 14. From this value we can find out the V2 value. Then we know the TV relation, T2 by T1 the whole raised to V1 by V2 the whole raised to gamma minus 1. From that value we can substitute the V1 value and T2 value, we got T2 value. Then heat supply QS equal to MCV into T3 minus T2. Here we know the value of heat supply and mass value and the CV value. So from this equation we have to find out the T3 value. T3 equal to 2026.3 Kelvin. Consider 2 to 3 equation. 2 to 3 means process, 2 to 3 constant pressure heat addition. From this we can find out the value V3 value. Okay, that is V2 by T2 equal to V3 by T3. So we know we can find out the value V3. So then cutoff ratio rho equal to V3 by V2. So we know the value of V3 V2. So finally we got the cutoff ratio rho equal to 2.37. From that the air standard efficiency equal to neta equal to 1 minus 1 by gamma into R the whole raised to gamma minus 1. The rho power gamma minus 1 divided by rho minus 1. Substitute all the values, we get the efficiency equal to 57.42. Thank you.